Alright, so what I'm going to do is I'm going to take the 2x plus 5 diagonally up in this direction, and I'm going to take the x diagonally up in this direction. So this is just kind of a shortcut way of doing it. I'm going to go ahead and leave that -1 there. So taking the 2x plus 5 over to the right hand side of the equal sign means that we're going to take it up diagonally. So this is going to be 2x plus 5, and bringing the x up, we have 3x plus 6. Alright, I'm going to now multiply and distribute this x across, so this becomes 3x squared plus 6x is equal to distributing this negative through, so we have negative 2x minus 5. And now I'm going to go ahead and take this stuff over to the other side of the equal sign, so we have 3x squared plus 6x plus 2x. Remember, we take it over, the sign changes, right? And that becomes a plus 5. And that is all equal to 0. So now we want to collect up our like terms, write this thing in standard form. 6x plus 2x is 8x, and then plus 5. And that's all equal to 0. Alright, so now we want to factor this. Well, the only thing that we can possibly do is write a 3x and an x, because 3 times 1 is 3. Alright, those are the only two factors of 3 and 1. So 5, it's either going to be a 1 or a 5, or a 5 or a 1. We want to get a positive 8 here. So if I were to put a 5 here, that would be 3 times 5 would be 15, and 16. No, that's not going to work. So we're going to put a 1 here and a 5 here. And of course, we're going to put a plus and a plus. Right, 3x times 1 is 3x, and then 5x and 3 and 5 is 8, and 5 times 1 is 5. So now we set both these factors equal to 0. And we have x is equal to negative 5/3, right? Bringing the 5 over, you get negative 5, and then moving the 3 diagonally down. And then, of course, this one here, x plus 1, setting it equal to 0. And we have our other solution. So our solution set is -1, -5/3. That is going to be our solution to our equation, which is right here. Alright. Well, I'm not sure if I mentioned this or not, but what are all the possibilities when we have an equation? Well, we could have one solution. You could have two solutions. Well, you could have many solutions, or you could have 0 solutions. And there is another one. You could have an infinite number of solutions. So possibilities, right? No solution. Oh, well, then there's no solution. Well, I guess that falls under no solution. When we start graphing these things, when we start graphing these, not really equations, but I guess I won't mention it, but we can put a picture to a lot of this stuff and kind of see geometrically what's going on. So let's look at another one here.